Greetings, Dr. Will here. Welcome back to the serialization of What You Don't Know, Successfully Lead a Software Project Without Tech Expertise. Episode 19, Chapter 8, Protecting Your Investment, Maintaining Software, Part 1. Maintenance in software means much more than break-fix. All software development activities, from the very first notional concepts of the software system to the design, development, and deployment of a working system, produce artifacts, or should. Definition from the Software Engineering Book of Knowledge. Quote, software development efforts result in the delivery of a software product that satisfies user requirements. Accordingly, the software product must change or evolve. Once in operation, defects are uncovered, operating environments change, and new user requirements surface. The maintenance phase of the life cycle begins following a warranty period or post-implementation support delivery, but maintenance activities occur much earlier. Close quote. Maintenance, the activities necessary to keep the software system, including its documentation, current, begins as soon as any artifact is produced that is associated with the project. Artifacts, or documentation. Artifacts can be the product of any development process and include specifically the technical or managerial documents, plans, designs, diagrams, test cases, etc. that drive development. They are, basically, any recorded information relevant and essential to the project. As the system evolves, so should the artifacts. In some problem domains, there may be strict documentation standards imposed by the customer. In others, not so much. A SaaS MVP might choose to forego most or all documentation to be in the market faster to validate the product notion. However, when bug fixes and new features start to bog down, the lack of documentation will start to pinch, especially if there has been significant tech churn. Configuration management, Chapter 11, version control, is a core part of the system maintenance discipline precisely because it tracks changes. The system's evolution is represented by the evolution, the sum total of changes over time, of the documents describing it. Some artifacts are merely superseded, but many are updated to reflect further, more profound understanding. While the evolution of the ideas may not be necessary to understand the current state of the development work, the current state of that information certainly is. Ultimately, a lack of documentation may pose an existential threat to a project. For a SaaS product, it may be an existential threat to the startup. The problem for at least some projects is that there is no documentation, none, and the only thing retained is the code base. Any useful software system will be sufficiently complicated to require some guidance in understanding the code. A lack of documentation suggests an underlying assumption that the code is, quote, self-documenting, close quote, well-structured and well-written. Well, no, it isn't. It is often not until maintenance has begun that the realization sets in that it would be really nice to have something more than just the code as a basis for understanding the system. For a non-technical founder or manager, the first indication of trouble is the set of metrics reported by the technical team. The number of defects, especially those reported by customers, the effort required to fix them, the difficulty, time, and budget required to implement new features, and so on, may indicate that all is not well with the system. Upon inquiry, schedule slips and budget overruns may be blamed on the average or bad code quality and lack of useful documentation. Unless the code is rewritten and documentation developed, reverse engineered from the existing system, then as the system is repeatedly patched, it will become increasingly difficult and costly to make each subsequent patch. It is argued by advocates of some agile development methods that documentation is not needed. When confronted by a defect needing resolution or a new feature requiring development, the team should simply storm the problem, sketch their current understanding of the system on a whiteboard, and use that informal model to answer questions about how the system works, and on that basis decide how to repair or extend the system. The assumption is that the current team recalls all of the salient details and their recollection is accurate, complete, and correct. But the current team is not necessarily the team that developed the software. Even if they are the same people, they aren't the same people they were months, perhaps years ago when the system was programmed. When asking them about some detail of the system, don't be surprised to hear, I don't know, I slept and had a beer since the last time we looked at that. Despair is that sinking feeling of money draining away. The technical team certainly won't be the same people after the project has experienced a bout of tech churn, and there are new developers who didn't write any of the legacy code. A project may go through various staffing cycles as funding waxes and wanes. How much time and effort will it take to reconstruct an understanding of the system to solve the problems without creating new defects with a completely new team of developers?
This is not to argue for documentation's sake. There may be documentation required by standards bodies in the problem domain, for example, the phased deliverables for a HIPAA-compliant software development in the medical arena. There may also be a documentation required by the customer. Government contracts often specify the documents required as part of the bid. In such cases, the documentation is developed as a specific product deliverable with the code. Where there is no customer or domain-imposed requirement, the documentation that should be produced would be that which is necessary for the long-term support of the system. Agile practitioners often shun documentation, but officially, Agile methods embrace necessary documentation and include an Agile process for managing it. Developers will not necessarily think like a product owner and consider the product's entire life cycle. A developer moves on down the road to the next development project once development or their involvement with it is finished. What if all the developers currently working on the project suddenly left for greener pastures? A new team would need to be hired to take over the work. How would they do that? Read the code is a long slog to figure out what's going on. It may be a very long slog if it's poorly written. Sans any design documentation, there is no guidance as to what part of the system does what. Poorly documented systems are difficult and expensive to maintain. Defects. Better developers write better code. They are always in short, expensive supply. Chances are best that the code will be of average quality, written by average developers. That means that the code will have its share of defects. There are no bugs in software. Admiral Grace Hopper, a pioneer in computer science, was the only person to ever debug a computer. Noticing that incorrect results on the computations of the ENIAC-1, she investigated and found a moth smashed between the contacts of one of the many relays in one of these first-generation electromechanical computer. She secured it, cleaned off the relays, and taped the bug in the log. Unfortunately, the word defects has 2 syllables and bugs has only 1. Plus, debugging is easier to say than what? De-defecting? The point? The term bug is here to stay, but bugs have autonomy. Bugs crawl in where they are not wanted without any human intervention and proceed to wreak havoc. Defects, on the other hand, are created by fallible human beings. Before any code is written, there are no mistakes in the code. Only after the developers start writing code are defects injected into an otherwise correct, albeit trivial, system. Acknowledging our fallibility aids in adopting egoless programming. Watch for the use of terms like bugs or glitches that mask responsibility.
That ends Chapter 8, Protecting Your Investment, Maintaining Software, Part 1. Join us next time for Episode 20, Part 2 of Chapter 8. That's it for me, for you, for now. Be careful out there. Bye.